Hello everyone. In this video, let's discuss how to find the prime number of set bits in binary representation. Given two integers left and right, return the count of numbers in the inclusive range, that is left and right value has to be included, having a prime number of set bits in the binary representation. Recall that the number of set bits an integer has is the number of ones present written in binary. For example, 21 written in binary is 10101, which has 3 set bits. Okay, so here they have given the input value 6 and 10. So from the range 6 to 10, we have to find what are the numbers that has prime set bits. So when I take the value of 6, the binary value of 6 is 110, that is 2. 2 is a prime number. When I go for the number called 7, the binary value of 7 is 111, 3 set bits, 3 is also a prime number. When I go for the number 8, the binary value of 8 is 1000, 1 set bit, 1 is not a prime number. 9, 1001, 2 set bits, 2 is a prime number. 10, 1010, 2 set bits, 2 is a prime number. So from the range 6 to 10, we have 4 numbers which have prime number of set bits. Now let's try to discuss the logic of this program. So let's take the input value 6 and 10. So here what we are going to do is we have to take a loop. We have to start the iteration. When we start the iteration, the value starts from 6. Okay. First, we have to find the number of set bits for the number 6. So already we have discussed this question, finding the number of set bits or number of 1 bits in a given integer value. So the logic is very simple. We have to take a loop. So until the value becomes 0. So let us consider this value is going to be stored in a variable temp. Okay. Until the temp becomes 0, I have to iterate the loop. Okay. Now what I am going to do is I have to find AND operation for temp and temp minus 1. So you have to keep on repeating this process until the temp value becomes 0. How many times the iteration has been happening, that many ones are present in the binary representation of the given integer value. So temp is equal to temp and temp minus 1. So take a variable called count, initialize it to 0 and increment this value. So this has to be present inside the for loop, because for every number that is for 6, 7, 8, 9, 10. So for every number we have to find the total number of set bits. So for that we have to initialize the count value as 0. For 6, count value will be 0 and we'll find it. When you go for the number called 7, count value has to be 0, we have to find the count bit. After finding the number of set bits, we have to check the count value is a prime number or not. Already we have discussed the logic of prime number. So by using that logic, we can find whether the number of set bits is a prime number or not. If that is the case, take one more variable, increment that value each and every time whenever it is a prime set bit. So binary representation 6 is 1, 1, 0. So 2 set bits we have, which is a prime number. So you will be incrementing one value. So let's take a variable called result. I'll increment the result. So for 7, the binary representation is 111. We'll get number of set bit as 3. 3 is also a prime number. So result value will be incremented by 1, which becomes 2. For 8, the binary representation is 1, 000. We'll get number of set bit is 1, which is not a prime number. When you go for 9, the binary representation of 9 is 1001. Total number of set bit is 2. 2 is a prime number. Result value will be incremented by 1, which becomes 3. When I go for the value called 10, binary representation of 10 is 1010. Total number of set bit is 2. 2 is a prime number. So result value will be incremented. So totally we'll have 4 prime set bits. Now let's try to implement this as a program. So here what we are going to do, we are going to start the iteration. So int I equal to left, I less than or equal to right, I plus plus. So we are going to start the iteration here. And from here we have to check the set bits. So how to find whether the set bits is nothing but I'll be taking a variable called temp. In temp I'll be storing the I value. So now while temp not equal to 0. So I'll be taking one more variable called count. In this I'll be finding the total number of set bits. So temp equal to temp and temp minus 1. And I'll be incrementing my count value. Fine. So after finding the number of set bits, I have to check whether it is a prime set bit or not. For that, I'll be taking one more variable called result. In the result, I'll be initializing the value as 0. Now what I'm going to do is, I'm going to do result equal to result plus prime of count. So I have got the total number of set bits, right? From here, I'm going to call a method called prime, and I'm checking whether that value is a prime number. If it is a prime number, I'll be returning 1, and that will be added to the result variable. If it is not a prime number, I'll be returning the value called 0. So 0, when I'm adding a number with 0, we will get back the same number. So now let's define the logic of prime number. Public stat int prime int NIL. So we are going to find the logic of prime number. For I'll be taking a variable called int I equal to 2, I less than or equal to math dot square root of n I plus plus. So we can start the iteration from 2 and then we can end up to square root of n. So if the number is divisible, we can say that the number is not a prime number, so I'll give return 0. If it is not divisible, I can say the number is a prime number, so I'll return 1. So that value will be added to the result. Finally, from this function, I'll be returning the value called result. That's all. This is the logic of the program. Let's run the code now. Okay, we'll check what is the mistake. So okay. The reason is, what if the value of n is equal to 1? Then we should return that it is not a prime number. But in this case, 1 is also considering it as a prime number. That is why we have got one value extra. So for that, I'll give one condition saying that if n is equal to 1, I'll return 0 saying that it is not a prime number. That's all. Let's run the code now. As it passes the test cases, let's submit the code. As it passes all the cases. That's all.